Hello, online students. This is Mr. Castle's class. It is August 19th, August 18th, 2016, whatever date it is. We're about to partake in our rest of our notes today. Please enjoy.
That is a fabulous introduction. All right, except for that, yeah, one little mess up. All right, the mole. Here we go. The mole, and we know we're going to be hearing this word all year. Okay, it's important. All right, it is the number officially. An official definition is it's the number of carbon atoms in exactly 12 grams. Y'all can't see that, hang on. Of pure, now what does that mean when I write carbon like that? That's isotope, that's the isotope of carbon that has a mass of 12, right? And we know 1 mole of anything is how many? 6.02 times 10 to the 23rd. Units of that thing, whatever it is you're talking about. Might be molecules, it might be atoms. Okay. Yes, particles. Yes, thank you. Of that, I'm going to say that thing, and I know that's not scientific, but units of that thing, whatever it is you're discussing. It could be paper clips. A mole of paper clips is that many. That's perfect. Y'all trying to be more scientific than me. It's okay.
It was people that said it. I just told them.
All right, now we said this right here. We just talked about this. Molar mass is the mass in grams. And we're going to practice a little bit just to be sure we remember. Of 1 mole. And remember, we get that from our periodic table. That's the number 1. All right. So if I was wanting the molar mass of magnesium. Now here's something we need to get used to that I don't think all of us were quite there last year because I didn't require it. But let's really think about this year, not rounding anything until we get to the end. So that means when you look at your periodic table, and y'all are using the one that's the AP periodic table, I think it's usually 2 decimal places on that periodic table? It's usually about 2. So even though we rounded last year, let's not round any kind of, because we're going to use, when we write molar mass, we're using that in a picket fence for something, right? And remember, we don't round to the end. And that will help all of our answers come out the same. That'll help you get used to that. And then those of you that go on to take the AP exam, you'll be used to that. Okay? All right, so on your periodic table, and I don't have one. Don't y'all have one? I'm talking about your AP one. Just want to be sure we're saying exactly what it says. All right, if you look at magnesium, what's it tell you? Where is magnesium? Don't look, tell me.
On the left side.
Left side. Group 2. And y'all don't tell me right and left. You know I don't know right from left. All right. Magnesium on your periodic table says this, 24.30. And what units or do we put on molar mass? Grams per mole. Y'all remember that, right? All right, here's where we get in trouble sometimes. And it happened to some of us on our summer work, I noticed. Not a lot of folks, but it did catch some of you. What if it says you have to find the molar mass of nitrogen gas? It is N2. Do not forget your Brinkelhoffs. Okay, so it's not just going to be the 14. You're going to have to times it by 2. So it's N2. And nitrogen is 14.01 times 2. So what is it? Grams per mole. Okay? Just be careful. And then if you're doing a compound, you're adding everything up in the compound. Let's just do carbon dioxide. 1 carbon, right? And that is 12.01 plus, what's oxygen? 16.00. Are y'all on here? See, you're not on your AP one. That's why I said, y'all use the one that's on the test, because that'll get you used to the numbers you're supposed to have. Times 2, and then what do we get when you add all that up? 44.01, right? Grams per mole. All right, so y'all see what I did here. I'm using the numbers exactly as they are on your AP periodic table. And please, y'all, that's the one you need to use. Okay, you want to get used to this one as much as you can. And this is the one I'm going to give you a copy of for every test that you take.
What's it called?
It just says periodic table of elements, and it says do not detach from book up at the top.
I got it.
I think y'all have a couple of them by now. I gave you one to start with, and then I gave you another one in your little resource pack, didn't I?
I think I'm not sure actually. I got my speed.
All right, questions on molar mass. That's not too bad. But if you mess up your molar mass, you mess up your whole picket fence, right? All right. All right, percent composition, and then this is easy too. Most of y'all, this was one of your problems on your summer work, and most of you did fine on this. Just remember, if it's a compound, let's say that we had that CO2 a minute ago, when you find the percent of oxygen and carbon dioxide, there's 2 of them. It wouldn't just be 16 divided by 44. It'd be 32 divided by 44, okay? So then that just tripped up just a couple of y'all, but y'all, this is not bad math. This is pretty much, if we took out these chemical symbols, this is just plain old regular math you probably did in 6th grade or before, all right? The mass percent is just the mass of the element. And y'all, anytime, I think I told you this, but anytime you've got a test for me, any formula that pertains to that test, I'll put on a little cover sheet for you. So you'll have a cover sheet with your formulas, and you'll have a periodic table, okay? Even easy ones like this I'll put on there just as reminders. All right, over what? It's always part divided by whole, right? Part over total. So the mass of the whole compound. And then don't forget to multiply by 100. Some of y'all, a couple of y'all forgot to multiply by 100. But remember, if it's asking for a percent, you multiply by 100. All right, here's what I want you to do. Find me the percent of iron in, now this is a 2-part little thing here. You got to know how to do 2 different things. In iron 3 oxide, okay? So you got to write the compound correctly and then do your percent. And I'll give you all a minute or 2. Let's see if we can do that. You got a calculator. Okay. But remember, you don't worry about that Brinkelhoff rule if it's in a compound, right? You just do your charge and crisscross. You only worry about Brinkelhoff if it's alone.
So we would actually, what we doing today was just
Right, you gotta write the compound first, right? And using that AP periodic table, that means you gotta remember about everything in column 1 has what charge, everything, you gotta, and that stuff, y'all, really, things like oxygen and sodium and things like that, you should know their charge by heart. How do you write iron 3 oxide? Very good. Okay. Remember that Roman numeral 3 tells me that iron has a 3 charge, and we know that the oxygen ion oxide has a -2 charge, and I crisscross. All right, and remember, don't round, right? From your periodic table, we're going to take the whole numbers, And iron says 55.85 times 2, right? And oxygen is 16.00 times 3.
So we gotta find out how we, what's the, percent, what?
I'm just doing the mass, right? Is this what y'all are doing first? I'm just writing out every step. You might not be writing out every single step. And then you add them up. So that you can get your total for the whole compound. Is this what y'all are getting? Okay, that's your total. And if I just want iron, you can do both iron and oxygen, but it's just asking about iron. You take the mass of those 2 irons divided by the total times 100. So, and if you do this step by step, you've already got those numbers right there. It'd be, I'm going to do it right here, 111.7 divided by 159.7 times 100. What do y'all get right there?
69.943604.
All right, I'm going to stop right there, percent. Did you have those same numbers that I've got up there?
I got 111.16.
You did 55.85 times 2. Remember, I'm using the number from the AP periodic table.
Oh, I put 580.
Oh. Is that answer going to count as the correct answer? Yes. What you told me, yes. Okay. You know what you're doing. All right, any questions on that? That's not bad at all. Okay, just refreshing your memory. The next little thing is one of my favorite things to do in chemistry is this little calculation because it's easy. It always comes out like it's supposed to. If it doesn't, you can fix it. Okay? And we did last year, we did so many of these with that little forensic thing with the plane crash that you should be able to do this with no problem. And you didn't have any trouble with it on your summer work, I don't think. Okay? But this is just empirical and molecular formulas. And what's the difference before we write anything? Empirical means what? In your own words. It is. Empirical means it's in its lowest ratio, right? And a molecular formula for a compound might be in its lowest ratio, but it doesn't have to be. Okay? CH4 is the molecular formula and the empirical formula for methane. Okay? It's the same. So empirical just means it has been reduced. Molecular, it has not. That's the true form. So, oh, when you draw it, did we do that last year? Did we do that last year? I don't know if we did enough, though. We're going to do some later when we draw the structural formulas for it. Empirical would be like, okay, if we have CH, let's say CH4, that could also be the molecular formula for methane. But we could have C2H8
It'll still be the same thing?
it could, this is a different compound. This is the molecular formula. Can this also be, is this also considered empirical? No. But this would be the empirical formula for this because it's reduced. Okay? And as far as knowing the difference between the two, if you can recognize that one is reduced, you know that's empirical. If it's not reduced, it's molecular. Okay? And we know how, this is the easy part right here. This is the fun part to me because you always go through these same steps, and it's not always like that in chemistry. But you've always got these steps. You're going to assume 100 grams, you're going to convert it to moles using the molar mass, and you're going to divide by the smallest number, and the numbers you get become your what? Your subscripts. Good. If the result is not a whole number, you got to multiply through by something. Y'all remember that? Like if you get 2.5 for one of them, you got to multiply everything through by 2. You get 0.33 for one of them. Multiply through by 3. Whatever the smallest number is where you can multiply it through and get all whole numbers. All right? So let's see. Let's all do this one. I bet we can do this one. And let me see. I worked this one. This comes out nice and even. You don't have to multiply through by anything. Okay? everybody right now. First of all, you assume 100 grams, so it gives you a percent of one of them, but not the other one. But what should 2% add up to be? 100. Okay? So don't ever let stuff like that mess you up. Just use your common sense on stuff like that. So we've got titanium and oxygen. And if titanium is 59.9%, and remember we're going to make that grams, we assume 100 grams, then that must be, oxygen is what? 40.1 grams. Then we convert to moles using the molar mass. Y'all see if you can do that. Use your mass from the periodic table. And just ignore me. Y'all work it out, and then you can look up here and check, and we'll talk about it if we need to. I remember last year when we first started doing this, it took us a minute to remember that 1.25 and 2.51 aren't your subscripts. Okay, and I know that sounds silly now, but don't, sometimes when you're working through problems, you start thinking too fast. But just remember that that last step there is divide by the smallest. And most of the time you'll get a whole number. Any questions on this? And be honest now. This took, remember, assume 100 grams. That just means we change the percent to grams. We divide out by the mass to get to the mole. And then we're going to, whatever two numbers or three numbers, it just depends on how many elements are in that compound. We divide by whatever our smallest number is. And between 1.25 and 2.51, 1.25 is the smallest. So I divide both by the smallest. And these numbers become the subscripts. This means I have one titanium and two oxygens in my formula. Okay?
The problem, like, has to give you the percent for each of the elements.
It either does or it gives you a way to figure out what percent they are. Because you have to know that information.
Yeah.
Okay?
Like it's implied. that
Right.
oxygen-
Right. Exactly. Exactly.
So it's called the molecular formula, is that formula, the actual formula, or is it just?
Yeah, this of course is empirical, right? And if it asked you if you had something here and it wanted you to find a molecular formula, then you would have to know the mass of the molecular formula. Remember? And we're going to do that in a second. But this is your empirical. If I know that mass and I know the mass of the molecular and I divide, that's going to give me a number that says, well, my empirical is multiplied by that number to get the molecular, right? Okay, so that's what we're going to do that. That's why it says right here, if you're going to go from empirical to molecular, you need the masses. And you got to have the mass of both. And that the number that you get when you divide the two masses is what you multiply through this empirical formula to get your molecular formula. I'm speaking a different language, I know. I'm throwing out all these science words, but they're words you remember, right? Right? Speak to me. Okay. All right, let's try this one. I think, let's see, this is one where this is one where we got to find empirical, and then it gives us enough information to go from there to the molecular. Okay? Let's look at what elements we got involved. And y'all, especially when you're getting used to these AP type word problems, this is a whole new ball game. Okay? Underline your information if you need to. I still do that sometimes. If I've got a big lengthy problem, I'll underline it, because sometimes they'll throw a bunch of stuff at you that's not even important. Okay? So a sample of a compound is made up of nitrogen and oxygen. It contains 1.52 grams of nitrogen, 3.47 grams of oxygen. Okay? And the molar mass of that compound is 92 grams per mole. Determine empirical and molecular formulas. So in this problem, do I have to do that first step, assume it doesn't give me percents, it goes ahead and gives it to me in grams, right? So I just start from there. And I go from gram to mole, divide by the smallest, and use those as subscripts. And then that'll be my empirical. So let's do that. It's just like what we did above. And remember, the way they list them in the problem is the order that they're in the compound. Okay? They're given to you in the correct order. He is okay. Look, we just can't help this type of stuff sometimes. Do what now, Jordan? Hello? Hey. Oh, I do. Yes, ma'am. Mm-hmm. Timothy, Miss Ingram wants you.
Dress code.
Yes, she does. She is, I guess in Miss Harden's old office. I assume that. You're welcome. All right, so. You need me? All right, so did everybody get this?
Yeah.
No problem so far, right? And that, of course, is the empirical formula. It's been reduced. Now it wants us to take that and find the molecular formula. But remember, to do that, we have to have the molecular or the molar mass of the molecular formula. And it gives us that, doesn't it? It says it's 92 grams. So if I know this mass, and I can figure that out, can I? And it's going to be 14.00 plus 16, or 0.01 plus 16.00 times 2. And what do you get for that? 46.01. All right. So if I take the mass that it gives me, 92 for my molecular, and divide it by my empirical, what you get? 2. And what does that 2 mean?
That's how much you multiply NO2.
I got to multiply through by 2, and that gives me what formula? The molecular. Very good. That sounds familiar? No problems. You get 2, is that right? Yep. So we're going to multiply. I'm going to just write it out here. If we got NO2, We're multiplying it through by 2. That's what this number means. So that means N2O4. That's the second answer to this problem. That's my molecular formula.
You figured that out without doing all that work.
Hmm?
You figured that out without doing all that work.
You're talking about the second part? It's kind of hard to figure out all of the first part. You got to be careful with the first part because if you end up with like 2.3, you know, you just got to be careful. But yeah, you could. I mean, you know what in your head that there's 2 46s and a 92 and multiply through by 2. That's fine. Yeah. You need me to write your pass? You got it?
That part, the second part of the second part.
The second part of the second part? Uh-huh. Right here.
Where'd you get 92?
It's in the problem. That's the mass of the molecular formula. And if I take that mass divided by the mass of the empirical, that tells me how much it multiplied through by. Okay?
So then whatever you give, that's the square for the.
That's what you multiply through by.
No,
See?
I said the answer.
Yeah, this 2, see, I'm gonna use that because this means that the mass of the molecular is twice the mass of the empirical, so I gotta multiply it through by 2. Got it? Okay. Any questions on that, y'all? Is that okay? This really is not bad. It's, like I said, because you get a set of steps that you have to follow every time. That makes life easy.
So you have a compound and say like it has, carbon, hydrogen, and all the like spread out, so it's not all like hydrogen's forward and the hydrogen over here. How do you know what order like?
Yeah, you're not going to get a problem like this where your elements are separated like that because it's got to give you the percent of it. And when it tells you the percent of hydrogen, it's only going to tell you that one time in the problem. Is there one like that on your homework or something? You would just add those percents up. Does it list hydrogen twice? I didn't, in one, for one,
It's no, it's like when it's the compound written out, and it's got like CHOH. We're talking about that. She has a view, but it's like
oh,
what order you would write in.
tell me what number. Let me look at it so I don't tell y'all the wrong thing. Where you at on? This is one of those questions where it's telling you that this is the formula for acetic acid, right? Is it in its lowest ratio? So isn't that the empirical and the molecular? So that's it. This is, it says, right, the empirical, and what is the molecular? But now you can change that. How do you write acetic acid? You can move it around if it makes you feel like, we know it's acid, so it would start with what? Hydrogen. And then what's the acetate ion? C2H3O2 with a 1 minus charge. So you can rearrange it like that if you want to. You remember, acetate can be written all kinds of different funny ways. Just, you know.
So you don't have to work yet.
No.
So really,
Because y'all, we haven't done structural formulas yet, and basically the question is just saying, what is its empirical and molecular formula, right? And that it would be both, but that formula serves both. Because it is the formula for acetic acid, and it's the lowest ratio. That's all I'm gonna say right now, y'all. I gotta get through some stuff. All right, because there's something about this one we need to talk about. I can't remember what it was, though. Hang on. Oh, boy. It says challenge important. This is a typical high-level college chemistry question. Okay? Freshman college chemistry question. Okay? And this is one of those where, yeah, we know the steps, right, of finding empirical and molecular. But we got to figure out how many carbons, how many hydrogens, how many oxygens we got before we can do anything. This is a really crazy problem, but let's look at it and see what we need to do. And we might just take some time just breaking it down today and seeing if we can figure it out tomorrow, okay? It just depends on how long this, just because I want us to really be thinking about some things. All right, it says a compound contains these three things: carbon, hydrogen, and oxygen. Okay? Combustion. What's a combustion reaction? It's going to have some kind of hydrocarbon, which is what this is, okay, plus what? What also has to go into combustion besides the hydrocarbon? Oxygen. Don't you need oxygen to burn? All right, so we know we got that, and we always get the same two products, don't we? Very good. Water plus carbon dioxide. So we've got some kind of compound here that contains carbon, hydrogen, and oxygen, and we got to figure this out. Bless you. Are you okay, Darius? You having an allergy attack, sounds like. All right. Now this compound, let's do this. I'm so sorry. Let's say we don't know how many C's there are. That's an unknown. You see what I'm doing? We don't know how many hydrogens there are. That's an unknown. Miss Brooker will be so proud of us right now. We don't know how many oxygens we have. That's an unknown. Okay? I've got three unknowns here. Okay? But then what does it tell me? This is just me working through this problem, thinking through it. It tells me that the combustion of 10.68 grams, so I'm going to start this reaction with 10.68 grams, right? Yields 16.01 grams of carbon dioxide and 4.37 grams of water.
So you can add those masses and then subtract that.
This is no simple process here, okay? So just take a deep breath and think about what this is saying. Now, if you get a problem, hey, y'all, here's an assumption here that we can make. If you get a problem like this, and it's giving you some kind of gram here on the reactant side and gram here on the product side, what do you think you're going to have to use at some point to get where you need to go? Picket fence, thank you. It tells us in the problem. It's saying it yields this reaction. It's not saying that's the molar mass, but this reaction yields. It's going to give us that much carbon dioxide and give us that much water. Okay.
Do we subtract the 176 10.68?
Well, what do we need this? Where's that number? What do we need this number for right here? That we don't even need to know the mass of the molecular until we get ready to find the molecular formula, do we? So that's not doing us any good right now. We need it later, okay? But what do I need to find out first is I need to find out don't I need to know how many moles of carbon, how many moles of hydrogen, and how many moles of oxygen? Because I don't have any percentages, do I? So I need to figure out how many moles. And when I figure out how many moles, can't I then divide by the smallest and come up with my subscripts for my empirical? See, that's the thing. When you're giving grams like this and you need moles and you're not giving any percents, see, this is what I talk about, one of those thought processes. What am I given and what am I looking for? I would not give this problem to you on a test on Friday, okay? But every set of notes we go through will have one or two of these challenging problems just to get us used to it, okay? What y'all think? Well, can we balance it though?
Yes.
Can you balance it if you don't know how many carbons, hydrogens, and oxygens you've got in that first comment? No. So we're not going to work, just listen. All right. I can go from moles to moles. Watch. Let's just do this. And y'all just, if you're having trouble, just know this is not on your test. But some of these different processes we got to know anyway. I'm just going to combine some things here. 16.01, this is for those that are ready to move on too. Some of y'all got this stuff and you're just ready for something challenging. That's good, okay? And I hope I'm able to challenge you all year. Y'all might be challenging me some once we get into some stuff I hadn't done since like 1994, you know, towards the end of the year. Wasn't that long ago. All right, let's say I know I've got this much carbon dioxide. Can I find out how many moles of carbon that it is? Can I go from grams of this to moles of carbon?
Yes.
I can say 1 mole of CO2 is how many grams? We found that out just a minute ago, didn't we? 44.0201? 44.01 grams, okay? Yep. Now, here's something I don't know if we did much of last year. I think they stuck in one of these questions every now and then. But if you've got 1 mole of CO2, how many moles of carbon do you have in 1 mole of CO2? There's 1 carbon, right? If I was looking for oxygen, for 1 mole of CO2, there's 2 moles of oxygen, see? 1, 2. And I'm just wanting carbon, though. I've got 1 mole of carbon. And y'all work this out. I worked it out a couple nights ago. I think I got this, but y'all just, you know, always check behind me. You know, he just does chemistry all afternoon when he gets home, so he, you know, he checks me all the time. Some of y'all had a mother that actually taught something you were having a hard time in. Do you think you would take advantage of that? It's almost like he's got a mental block with chemistry when it comes to anything. I mean. Okay, so we just had a little rounding difference there. I'll change it right there. Does that make y'all feel better? All right, did y'all get close to that anyway? Okay. All right, so anyway, now let's do our water here. And why do we need to do this? Because this will tell us about hydrogen. Okay? And we should remember the molar mass of water. We used it so much last year. 18. And I want to know my hydrogens this time. So 1 mole of H2O is how many moles of hydrogen? How many hydrogens do I have? 2. If it was asking about oxygen, it'd be 1. All right, 2 moles of hydrogen. And I got 0.486. .486. All right, y'all. Is anybody else getting 486? Okay. Hello? Hey. Yes, hold on. Allie. Oh, sorry. Miss Tyson. All right. I got all this worked out, but I think I'm going to stop now because if I get into the next little step, it's going to take too long. Okay, listen, let's stop here. We'll pick up right here tomorrow. Let me stop this, and then we have a few minutes if y'all have a question about your homework.